Thanks, Luke. Hi, I'm Brad Buck from OpenCrowd, and welcome to our webinar with Sencha on building next generation fluid apps. My colleague Rajiv Sohal will be joining me in this presentation today. We'll start today by first characterizing the changing face of enterprise user applications and a solution for that. We'll also show you an example Ext JS based application to help you further understanding of this new solution we're defining here. And we'll also talk about some of the important design aspects of these applications before we head into Q&A. So let's begin. One of the largest areas of enterprise IT spend over the last 10 years has been in SOA-based initiatives. A key reason for this spend was to lower the cost of integration. As a result, the number of service endpoints has exploded over time. With these SOA-based implementations, it served as an opportunity to help streamline and consolidate processes within organizations. So, today, enterprise shared services is now not only a familiar concept, but a common practice in many organizations. So SOA really helped to address one of the key integration challenges of its time, but there's going to be new challenges that are unmet. What we've seen with SOA is that while there have been many benefits to their adoption, and it's a best practice in most organizations, it's generally fallen short of business expectations. SOA efforts focused on revamping backends, which is largely replaced or consolidated functionality with minor improvements for your end users. So with all this heavy lifting being done, the face of the applications has really not been impacted significantly. As a result, really, the business tends to view these efforts as being largely IT-driven, and that's why we have a reason for shortfall of expectations. So what we find really is after SOA implementations, many of the applications remain siloed still, and they're centered around the business processes. There's really been little effort to consolidate front ends around how users need to work. And meanwhile, while this implementation has been going on, the users' needs have continued to change and evolve, and that's been at an increasing pace. Today also we're finding that users are being asked to perform more tasks, often across business processes. These tasks are demanding more problem solving and analytic skills, as well as a need for increased use of collaboration tools to accomplish their jobs. To meet really the user needs, a new approach need to be taken. This needs to allow for front-end applications to evolve more quickly as user needs evolve and are driven by those needs of those user bases. The applications need to streamline those user processes by working the way that they actually do their own work. They need to take full advantage of the SOA investments, which will better demonstrate the benefits of all those investments have been put into that infrastructure. And what's really needed is this more focus on the user process layer that sits above your business services. And this is the opportunity to help realize this, realize the true benefits of the SOA and address the shortfall of expectations. When we're looking at building and architecting new applications, there are several real key considerations that we need to factor in to the architecture. So today our businesses are evolving or even remaking themselves at an increasing pace. This pace of innovation is expected to increase, and the business expects that IT will enable that evolution and innovation. There are many driving forces that are causing for the more rapid change. There's new business models, competitive pressures, new products and services that need to be introduced. Another factor is in increasing efficiencies. And when you change a business process to increase efficiencies, you may not just be modifying the process, but you may be changing the user role from being business process executors to really exception handlers, which have a vastly different set of needs. Making effective decision-making requires providing information and tools that are easily accessible to your users. If you don't make them easily accessible, a user may not take those extra steps to find and look at that extra information or to use that extra tool that will help them to make an effective decision. Many of the technology drivers we see are continuing, evolution within IT. Our applications are increasingly becoming more sophisticated and more feature-rich. And while increasing this application complexity, we still need to maintain their costs while keeping delivery predictable and efficient. SOA is another changing enabler within organizations to help make a shift to this new paradigm. But we also look at the big leap in browser technologies over the last several years is also allowing us to take new approaches in building applications. So the architecture that is needed to support a more fluid needs of your users is what we call fluid apps. Fluid apps loosely assemble components that can be adapted and evolve continually to meet changing user needs. Fluid apps are driven by how your users actually perform their work, which is different from the way a business process gets executed. By moving the front-end integration or integration into the front end and using dynamic scripting, the next challenge for IT integration can be addressed. That is, getting data and the tools that you built into the hands of the users that actually need them. Ext JS plays a critical role in this new architecture. While your SOA is becoming more easy to integrate into your applications, you need a framework that actually supports more quick evolution and needs to become more adaptable and configurable as a result. These applications also will be agnostic to your services layer. This is not only for the services that you've developed, but also to allow and permit the integration of external services, be them for data or SaaS-based services. We're seeing as an ever-growing trend here is the use of more off-the-shelf cloud-based solutions within applications. So before moving forward, I wanted to just take a look at how business processes may change and what are the impacts of some of those changes. And this is based upon the definition of a loan origination process, looking at a current state and then a future state. So when defining this new process with a client, you really have to look at and examine what the users need to support themselves while executing a business process. So these includes a number of factors that when you're defining a business process, you normally would not consider as part of a SOA-based implementation. So you need to consider things such as the context of the work, what are their immediate needs, what are their pressures, what are the critical success factors that they have in their job, what are the different business processes that they may be looking to execute, what are the coordination points, and how do those processes connect or need to remain disconnected? And also, how do the users need to manage process exceptions and troubleshooting? Right? Those are normally outside the bounds of a business process and require a number of different external sources to be able to effectively execute. And also, there's going to be a number of collaboration points that you see among users. Those could either be clients to internal users or collaboration between different internal user groups. We're seeing an increasing need to integrate a number of different collaboration tools to effectively organize and execute business processes. So Ext JS plays a critical role in this new architecture that will help to more rapidly build these applications. And now I'll let Rajiv tell you more about building these apps and show you the example Ext JS application.
Thanks, Brad. So most enterprise applications need to integrate and interact with other systems. Let's first take a look at how current architectures approach this integration challenge. This is illustrated on the diagram on the left. The integration typically starts at the application tier. The application tier is responsible not only for connecting to various other systems, but also transforming and translating data and messages to a format that can be consumed by the client application. The actual communication could be in any form, could be XML or JSON messages, queues, or even remote EJB invocations. The presentation tier gets access to this data through the application services there, and the web tier, in turn, which is your browser-based application, has to go through the entire stack, the presentation tier and application tier, to get access to these services. As you can see, any potential integration will impact multiple tiers. And with this, the development complexity and the costs both go up. The applications also become inflexible and difficult to enhance or change based on evolving needs. Even to support a small change, every tier typically gets affected. Now, let's compare this with what ExtJS has to offer. ExtJS has a robust front-end MVC framework and a variety of data adapters that can quickly access enterprise services. With this, ExtJS has enabled us to move the integration to the front end and create fluid, configurable applications. These applications address the user's needs more effectively and are also cheaper to build and manage. Data integration represents a large part of any application. With the ExtJS, these services can be accessed directly from the browser, which drastically reduces the integration effort. Atomic services also, for example, very simple services that don't require transactions can also be directly integrated with the browser application without having to go through the need of going through the presentation services, the application services, and then to the root service provider. For complex transactional services, we still depend on the application tier down here. But we limit that also to purely orchestration and service connectivity. We have a model in place where we determine for complex actions what are the tasks or underlying steps, and the only responsibility the application tier has is to manage the orchestration and the transaction requirements for those. So overall, it's a much simpler approach. In all, the front-end integration approach vastly simplifies the integration architecture and allows browser-based user interfaces to be abstracted from underlying services, and get several benefits from that. Let us now take a look at the demo application. This demo is derived from the work we've done with various enterprise clients, and we've tried to showcase key capabilities and features and patterns that we use there associated with fluid applications. The demo itself is a commercial loan underwriting application that needs to integrate with multiple internal and external systems in a variety of formats. If you see like the architecture diagram at the bottom, you'll see that we're connecting to the CRM system, reference data, even risk systems through message queue, and also to external data sources. Let me quickly switch to the application now. For an application to be fluid, the user interface must be flexible to adapt to change and extensible to support new requirements. This demo application shows or showcases both these capabilities. It uses a base layout that we've implemented many times over with our enterprise clients. The user interface leverages extensive layout capabilities provided by ExtJS to provide the rich desktop type field, application type field that you can see, yet maintaining both the flexibility and the extensibility desired. On top here, we have what we call the user process manager, which is key in driving the fluid user experience. This is dynamically rendered based on the user's role and entitlements and the current state of the business process. In this example, for example, Jennifer has access to two workflows, which is the new loan applications and renewals and alerts. Each process has a set of queues under here, which reflect the workflow, the actual workflow associated with the business process. This is again driven by the workflow definition and the user's entitlements. A user may only have, for example, access to certain features. Jennifer may not have access to be looking at contracts, and that queue will automatically be reconfigured to not show that option available to her. The business process itself is also rules and configuration driven and can be modified or rewired without requiring any code change. In the center of the screen, we have the work items grid with the user's tasks along with the associated content. In this case, we have new loan applications, and we can see relevant data for those applications to allow users to take action. Each queue has a different set of columns. Again, these are configuration driven and can change to support new requirements. If, for example, I move to the alerts queue under renewals, you will see that the columns of information have changed. What is important, what is highlighted has also changed. In this case, we are highlighting alert types, so users can quickly focus on what needs attention. The user also has the ability to customize these layouts of the grid, be it sorting, filtering, or even changing the columns that are shown. This allows the users to configure this to more closely match how they work. It helps us build applications that are more generic and not try to go for specific solutions. It's more like a one-size-fits-all, where we expect all the users to follow or behave exactly the same way. To do this, what you see the grid here, we've extended the Ext JS grid and added some customization and usability features. It is also configuration driven and can be used for almost any type of data or application. If you have a separate user process or a business process, we can very quickly adapt this interface, extensible interface, to that by creating the user process workflows and then showcasing data from different systems and combining them with the tasks at hand. At the bottom, you will see this component. When I clicked on any particular row, I'm able to look at the details of the task. We call this the action panel or the work window for the selected item. The action panel contains both details of the work items here and the actions that can be taken on it. In the tabs below, it also brings together data and intelligence from multiple source systems to provide the insights needed to make a decision without leaving this application. If the user, for example, is processing a loan application and they need to look at different data from different sources, we've combined all of this into an extensible format of the tabs given below. If you look at the company profile, I can see this is maybe part of the application data, the profitability or the annual sales. And then we've compared this with another system and tried to give users the context of that information. For example, the industry average, the profitability appears to be lower than the industry average in this case, which may affect the user's decision. Throughout these tabs, we've gotten data from multiple sources. In this case, we've gotten information or a recommended credit limit from a risk system and tried to compare that with a real-time request to an external service done in Bradstreet as to determine what they recommend based on their risk models. So in essence, we have this extensible model where we can keep integrating additional sources of information as they become available. We've even, for example, integrated legal filings, and these are based on web searches and snapshots of web searches to various providers, and we associate that with the underlying loan application. These tabs themselves are fairly configurable. In a lot of circumstances, we can basically just add new sources of information by configuration only without any need for code change. Obviously, things that require more sophisticated views will require some code change, or at least some customization or rendering needs. So on top here, we also see that each queue has a set of actions that can be taken by the user. In this instance, Jennifer can either choose to mark an application for further review, approve the application, or reject the application. The actual action may by itself affect multiple underlying systems and processes and could be long-lived. For example, if I'm going to say I'm going to approve this application, let me quickly put in a comment. This particular action could have fired multiple events. A request could have gone out to update the CRM system or the accounting system. A request could have gone out to generate a contract and also a confirmation email to the applicant. To handle these distributed tasks effectively in a web-based system, state management is very important. We need to keep managing the state or recognizing the state of the application in a scenario where the request goes to multiple systems and is being worked upon simultaneously by multiple users. ExtJS offers very well-structured client-side storage models. This allows us to replicate and synchronize states across systems, making it very easy to automate these tasks and manage state throughout the process of the user. So next, we would like to share some key elements of our experience with building these applications with ExtJS. Let me just switch quick back to the presentation. These include both the development approaches that we have taken and some aspects of technical design. So first off, we have some patterns around user interface design and the implementation path taken. From a UX design standpoint, for fluid applications, the user interface must be designed to both be flexible and easy to extend. We should also focus on how users actually work and think beyond system and organizational boundaries. It is not sufficient to automate a process where the user is still required at some point in time to swivel chair to another system and then come back to complete the task at hand. At least from a design perspective, we should extend this to more, to be more flexible. We should also focus on one other thing that we've used is rapid prototyping with the ExtJS. It is relatively easy to prototype the applications using the sample stores and models and showing the user what the application would look like and getting effective feedback and some initial validation. It makes the design process more iterative and gets us closer to what the users really want. One key factor with design, UX design with the ExtJS is, or for fluid applications, is that the design should be kept simple and interdependencies in the views themselves should be limited. For example, we could have a grid which probably shows you columns from 5 different services combined together. It just makes the implementation a bit more difficult and more tightly coupled, and that goes against what we're trying to do with a loose assembly of components. In certain cases, it may not be avoidable, but we should try and keep away and keep to simpler designs and loose interdependencies. From an implementation standpoint, one advantage of ExtJS is that we see it as purely a service-based application. So the user interface can be developed independently, and the services layer can be developed in its own path. We create and maintain a full service catalog. This includes every possible interaction from the ExtJS application to either its native application server or external applications. It also makes it easier for us to work with other groups in an enterprise because the responsibilities are clearly defined and there are not too many interdependencies in their development schedules. It's easier to leverage the static stores provided by ExtJS to have the UI development continue and not wait for some underlying service to be delivered. It also makes it easy to deploy the user interface and the service independently, and also have these tested independently before end-to-end integration testing. The next key thing is authorization and entitlements. From a security perspective, we found that our ExtJS applications work well within the enterprise SSO and entitlements frameworks. Most enterprise applications have shared entitlement services, and we typically access these from the application tier, which in turn injects the security context into the ExtJS application on initial load. So typically we have a security model or an authorization entitlements model, which is populated by the application layer, and when the ExtJS application, the web UI loads, that context is injected. This allows the web interface to be completely role and entitlements based, makes it very flexible. Just like you saw in the demo application, Jennifer had access to 2 different workflows, and that was purely based on her entitlements. If, for example, we remove one of the entitlements, that workflow would have gone, disappeared, or been removed from her system. As the ExtJS application is web-based, and in certain cases we do access these services directly, we do expect that the service provider will revalidate the entitlements and authorization, because it's very easy to hit a RESTful URL directly from a browser, and it is important for them, and that's a pattern that we've used successfully. So ExtJS, with ExtJS, there are several options to integrate with external services. The options used can vary from service to service and is determined by the factors such as security requirements, established best practices within the organization, and the deployment architecture. For simple data-based services, reference data could be static taxonomy data, or simple non-transactional requests, function requests. We prefer client-side integration and use JSONP to, go over the cross-domain issues with web service access. For services that are transactional, long-lived, or touch multiple systems where it is important to distribute or coordinate a transaction across multiple systems, we still prefer code-based integration, or integration at the application tier, or orchestration at the application tier. This is also true with certain cases where your remote services may only, for example, provide you a remote EJB. So in that case, you probably would not have a choice, and you will have to go with the application tier approach. There is a case when direct access, even though a service is a candidate for direct client-side access, that is not an option, either because of security or other compliance reasons, or maybe a deployment infrastructure issue. In this case, web server or code-based proxies can be used, and they tend to work reasonably well. Moving forward, we did talk about orchestration of distributed functionality in the example that the demo application that we've chosen. When we enable user workflows across enterprise systems, there are times when the user action can result in multiple steps, and these steps can affect multiple systems. For example, in the demo application, if Jennifer approves a loan, it may result in the CRM system being updated, or contract documents being generated, or an email being sent out. For a scenario like this, we use rules-based orchestration. So if you notice here, a request for an action from the user is passed to the application tier, which in turn runs it through a rules server. The rules server basically determines what underlying actions are needed to complete the action the user wants, and in what sequence or orchestration priority. The application tier then simply has to go and execute those steps and coordinate these with the multiple underlying service interfaces. The advantage of this approach is that it's very easy for us to change orchestration, as it's purely rules-based. And it makes it totally configurable and reduces the need for code changes as the application needs to change or evolve. Lastly, we did see some concepts of the demo application to a great extent was configuration driven, and we also saw some customization of options. We do tend to make our user interfaces configuration or data-driven. This enables the application to very readily adapt or change if a user requirement changes or there is a change in the business process. It also allows our UI components, such as the grid we saw, to be reusable. We've used that same grid component, the customized version that we have extended, across a variety of applications. It's purely data-driven and dynamically configured and can be pointed to almost any data source. We also saw user customization. User customization allows us to build, to avoid building for one size fits all. It gives the user more flexibility in terms of how they work and having the application support the way they work. The customization options do not need to be limited to the grids. They could also, for example, be a layout or the ability to drag and drop new components and widgets onto a screen. And those options are actually limitless, being able to drag a new data source or component. So those are some of the features or benefits that we get from the customization and configurability that these applications provide. With this, let me hand this back to Brad for questions.
Yeah, actually, this begins our Q&A section, so I'll leave this to Luke to moderate this, as I believe a number of questions have been coming through during the presentation.
Okay, so we've got a few questions here. So the tabs that you showed in the demo application, are they all making HTTP, AJAX, XHTTP requests to outside sources to correct the data package and proxies?
There are multiple approaches that we've taken. In certain cases, these are native, basically, JSON requests to the application server. And in a couple of cases, they're actually HTTP requests to external sources. And the data is combined and rendered accordingly. So each tab basically has a different one or more data sources associated with it, or a model or client-side store associated with it.
Okay. Another I have here is, are you making use of ExtJS state management providers for customization, or did you roll your own?
This instance, we did roll our own, because it had some very specific requirements of data entitlements. And this is something that we've worked with over a period of time, or developed over a period of time.
Okay. And then the last question I have here is, how do you combine into a store model disparate data in your presentation view to reduce the interdependency of views?
I'm sorry, could you repeat that question?
Okay. How do you combine into a store/model disparate data into one presentation view to reduce the interdependency in views?
So this could either be done at the service tier using a composite service, a light composite service, or done upon loading of the data through custom handlers. But our recommended approach is to avoid doing this wherever possible. Keep the stores and the models relatively simple and reduce those interdependencies. We did see one example where we were showing the application information and we were showing public benchmarks. Now, there are two approaches to doing that. We could have either combined it into a single composite service or model, which brings that together, or we could bring those pieces together on the user interface itself, or basically render them next to each other. We chose the latter, of being simple atomic services being brought together when it's rendered.
Okay. If there's any other questions, please ask them in chat now, or we're going to probably wrap this up here. I'm not seeing any of the questions here in the chat pod. I've got people putting their hands up, but they're not actually typing it in. Do you use local storage that you load up during startup?
For a lot of the taxonomy data, we do that. So, for example, the workflow configurations, the queue states, are all loaded on startup for performance reasons.
Okay. Rather than going into the storage each time. Okay, yeah, I think you just answered that. Okay. Okay, we have two questions here. What programming language, I guess they're asking on the back end for this app, and I can take the how would you compare ExtJS with Dojo, but I'll let you. What are you guys using on the back end?
So on the back end, we have applications that look and behave almost similar to what we saw before, and on a Java stack as well as an open source Django stack. Python Django stack, and there's not much difference in the approaches. Especially in any enterprise, we do have services that we connect to, even in a single application, that are written in multiple languages.
Okay. The question I have here is comparing ExtJS with Dojo. That's there's a lot of differences, a lot of deep stuff in with that. So they both are different frameworks that both have different paradigms. I really recommend taking a look through the Sencha website and the Sencha forums for comparing ExtJS with Dojo. Dojo's owned by IBM at the moment. However, IBM is a big user of ExtJS, if that says anything. We've got a few more questions coming in here. Are you using REST for your data object access to the backend?
Yes, all our service requests are typically REST-based.
Okay. What are the limitations you've encountered while building your application in respect to ExtJS?
In terms of limitations, I can't think of many. Certain cases we did have some performance issues with the grid, but with newer versions of the ExtJS, they seem to have been addressed greatly. There are, we have to be careful when using components because they can tend to be deeply nested in terms of how the HTML or the DOM is actually generated. So as long as we stay within the framework and we use a bit of prudence, we have found the ExtJS to be very effective.
In ExtJS 4.2, there was a big push to improve the performance of the grid and come up with a couple of ways of really keeping that DOM tree smaller. So yeah, that's a lot of the main issues. We come out with new versions, we listen and really address what's coming out. So how are the components in the view created using ExtJS? They're rendered by the framework when it on load. I don't know if there's a better answer for that one. What best practices do you recommend while architecting the application? That's a really big question as well. If you want to take a shot at it, otherwise I refer people to, we had a best practices webinar on ExtJS and JavaScript last month, and the recording is in our Vimeo channel at vimeo.com/Sencha, and that's what the recording of this will be also. But if you want to talk about any best practices, please do.
We did share some of our approaches that we've taken in terms of how we design the user interface to be flexible and extensible, making things configuration-driven, maintaining a service catalog. So some of those things have really helped us in our engagements. And also our concept of how do we address distributed functionality using rules engines. And those are some of my initial thoughts.
Okay. Well, I think we've had a really great webinar and online user group meeting here, guys. Again, this is Lucille Patrick. I want to thank all our participants here that joined in. We've had well over 70% of the people that signed up for this attend. So we'll have the video up later today, and we'll forward a link on the meetup group as well as through any of the channels that OpenCrowd has. So thanks again, everybody, and I'm going to end the recording, and have a good day.
Thanks, Luke. Thank you, everyone.
Yeah, thanks, everyone.